So far, we have covered some basic concepts. I would say all basic concepts in ER modeling. What we will cover from this slide on is more advanced concepts. We will start by talking about many-to-many relationships that can have multiple occurrences between the same instances of involved entities. Let's look at an example. Let's look at this example. Each student completes between 0 and many classes. Each class is completed by between 1 and many students. Every time student completes a class, we keep track of what semester did student complete that class and what grade did he or she get. Let's look at some of instances of this relationship takes. For example, Amelia completed 1 class, Max completed 2 classes, Teresa didn't complete any classes, and Aaron completed 2 classes. Let us now slightly change or expand this example where we allow same student to take same class more than once, probably in the case they didn't receive the passing grade yet. So what we're showing here is Max taking conflict mediation more than once. This makes dealing with this problem quite more complicated. We are no longer able just to use a many-to-many relationship. Instead, we have to supplement this many-to-many relationship takes with a weak entity, which we call here test completion. The explanation of this issue is given on pages 42, 43, and 44. The solution shown in the previous slide assumed that each employee can take only one proficiency test on a particular date. If we change the requirements to allow employee to take multiple proficiency tests on the same day, as long as it's not the same type of test, the problem gets even more complicated, and now the weak entity has 2 owners and 2 identifying relationships. This is explained in detail on page 44. Here is another example of a many-to-many relationship with multiple instances between the same entities. In this case, same customer can rent the same car more than once, and that's why that many-to-many relationship rental has to be represented as a weak entity. This example is elaborated on pages 44, 45, and 46. This example here shows how adding a unique attribute to this many-to-many relationship eliminates the need for a weak entity. The moment the entity has a unique attribute, it's no longer weak. It's a regular entity, and all of a sudden this whole scenario simply involves 3 entities and 2 one-to-many relationships. This example is elaborated on pages 44, 45, and 46. Associative entity is simply an alternative way of depicting many-to-many relationship. Associative entities do not have unique or partially unique attributes, and often they do not have any attributes at all. This example, that is elaborated in detail on pages 46 and 47, simply shows how many-to-many relationship can be depicted both as simple many-to-many relationship, or it can be depicted as an associative entity. These 2 diagrams shown here are completely identical. Here we see a many-to-many unary relationship depicted also as an associative entity. Again, these 2 diagrams are completely identical, and they're discussed on pages 46, 47, and 48. And finally, we see a many-to-many relationship with an attribute also being depicted as an associative entity with an attribute. Again, these two diagrams are completely identical, and they're discussed on pages 46, 47, and 48. Associative entities are not very useful for binary relationships. They provide an alternative, more complicated and verbose way of depicting something that's already depictable in a simpler way. However, for a relationship with a degree higher than 2, such as ternary relationships, associative entities do provide a way to eliminate potential ambiguities in the ER diagrams. Ternary relationships are relationships that involve 3 entities. The degree of those relationships is 3. In the next few slides, we will show some ternary relationship examples that are discussed in much more detail on pages 48 through 51.
Let's take a look. First, we will look at an example where there is no ternary relationship. This example shows 3 binary relationships between supplier, product, and component. Let's see what's depicted here. Each supplier provides for between 0 and many products. Each product has between 1 and many suppliers. Each supplier provides between 0 and many components. Each component is provided by 1 or many suppliers. Each product contains between 1 and many components. Each component is contained in 1 or many products. We see all kinds of things here, but here's what we don't see. We don't see a relationship that shows which component for which product is provided by which supplier. That is missing piece of information here, and something like that you can't depict with 3 binary relationships. Instead, you need a ternary relationship that will show us which component for which product is provided by which supplier. The problem with ternary relationships is that it's difficult to show cardinality constraints. That's why they're not shown here. Let's say we have a cardinality constraint, mandatory many next to component. What would that mean? Is that mandatory many for product or mandatory many for supplier? It's ambiguous. It's actually impossible to clearly indicate, does it refer to supplier or product? Because of that, we don't depict ternary relationships as we showed on the previous slide. Instead, we use associative entities. Associative entities eliminate ambiguity of cardinality constraints in ternary relationships. It is clear what's happening here. We have an associative entity providing, which indicates instances of a supplier providing a component for a product. Each supplier can participate in between 0 and many instances of providing a component for a product. Each product must have at least 1 instance of a supplier providing component for a product, but can have many. And each component must be involved in at least 1 instance of a supplier providing component for a product. Each instance of providing a component for a product by supplier is associated with exactly 1 supplier, exactly 1 product, and exactly 1 component.
Here's a trick how to avoid ternary relationships altogether. If we're able to add a unique attribute to the ternary relationship, we can convert it into an entity, as is shown here. Ternary relationship providing is now replaced by a regular entity SPC instance, meaning supplier product component provision instance. And we also invented this unique attribute which we call SPC code, which simply gives a unique attribute to every separate occurrence of a supplier supplying a product with a component. By adding this unique attribute to the relationship, now we can convert the whole relationship to an entity, and we can add other attributes such as date since.
However, that's not always possible, and sometimes we may have to be stuck with a ternary relationship, and that's fine. It turns out that ternary relationships make sense only if there are many to many to many relationships. Let's look at this ternary relationship, which is not a many to many to many relationship. Instead, it's a many to many to one relationship. What does this mean? Each supplier can be associated in many instances of providing component for a product, but does not have to be associated in any. Each product is associated in at least one instance of supplier providing component for a product, but can be associated with many. Each component is included in exactly one instance of a supplier supplying a product. In other words, every component is custom made by one supplier for one product. It can be used in any other product, and it can be made by any other supplier.
Well, if that is the case, then we don't need a ternary relationship. We can replace the ternary relationship with two one-to-many relationships. Remember, each component belongs to exactly one product and exactly one supplier. It's custom made by one supplier for one product. So if we wanted to find out any relationship between a supplier and a product, we can simply go through component. This example illustrates that other than many to many to many relationships, ternary relationships are not necessary. Not for one to one relationships, or one to many to one, or one to many to many. Again, a greater discussion about ternary relationships and these examples is given in the book on pages 48 through 51. In practice, ternary relationships are relatively rare. Relationships of a degree higher than 3 are extremely rare. In fact, you could have an entire career in database design and never see a relationship of a degree higher than 3. We will conclude our coverage of ER modeling by giving a brief discussion of how number of attributes in the diagram can be reduced by treating some attributes as attribute values. That is valid in some circumstances, but not always. This issue is illustrated by the example shown here and discussed on pages 51 and 52. Here we see entity employee, and for each employee we keep track of a unique employee ID, employee name, and then bonuses for 4 quarters. The diagram shown in the previous slide can be also depicted as the diagram shown here. They both satisfy exact same requirements. Instead of showing 4 attributes for bonuses, we show a weak entity bonus with a partial unique attribute bonus type and bonus amount. Both approaches work fine. In fact, if every employee has a bonus for each quarter, then either alternative works just as well. However, if some employees don't have bonuses, this may represent a bit more elegant solution. This concludes Chapter 2.